Hello, and I want to welcome you to solving an equation containing rational expressions. So the steps are to first determine the LCD of all rational expressions in the equation, multiply both sides of the equation or all parts of the equation by the LCD. 3. Remove any grouping symbols and solve the resulting equation. Then the optional step would be to check the solution of the original equation. So looking at number 1, we have 3 plus m over 5 equals 9. So what I would first recommend doing would be to get rid of the 3 because it is farthest away from the variable on its side of the equation. So when subtracting 3 on both sides, we're going to have m over 5 equals, we have 9 minus 3 is 6. Now noticing that m over 5 is a fraction, and that can be noticed as division, and do the opposite operation to get 5 by itself. So instead of dividing by 5, let's multiply by 5 on both sides of the equation. And this 5, the multiplied and the 5 in the denominator will free the variable m, and we just have 6 times 5 is 30. So we're saying that m is equal to 30. Now we need to initiate our check. So write our original equation of 3 plus m over 5 equals 9. Now let's have 3 plus what we think m to be is 30 over 5 equals 9. So 3 plus, and then 30 over 5 is 60 equals 9. So 3 plus 6 is 9 equals 9. That is a true statement, so that means m is equal to 30. In our final example in this case, we have h over 2 plus 5h over 4 equals h over 12. So the important thing to note is that the LCD is something that all the denominators can go into. In this case, I believe you'll note that everything can go into 12 because 2 can go into 12, 4 can go into 12, and 12 can go into 12. So 12 in this case will be the LCD. According to our rules, we need to multiply the whole thing by the least common denominator. So we have 12 times the quantity h over 2 plus 5h over 4 equals h over 12. And we do that, we see here that 12 times h over 2, we're going to be left with 6h plus 12 times 5h over 4. That leaves us with 3 times 5h equals, and we have 12 times 12 over h over 12, leaving us with just 12, or just h, excuse me. So simplifying what we have 6h plus 3 times 5 is 15, include our h, equals h. So let's combine our terms. Over here we have 6 plus 15 equals h. So to get all the h's on one side, let's subtract h. So it's going to be 6h plus 15h minus h equals 0. Alright, so we're going to have 6 plus 15 minus 1 is going to yield 20h equals 0. To finally get h by itself, divide both sides by 20, freeing the variable h. So anything over 0 is 0 for our purposes here, so h is equal to 0. That's nice, but now we need to initiate our check. So what we need to do is rewrite our original equation. So I'm just going to clone what I have here. And we think that h is equal to 0. So what we need to do is go through where we see h and just replace 0 in parentheses with every h present. And if you look, 0 over 2 is 0, plus 5 times 0 over 4 is 0, plus 0 over 12 is 0. So 0 plus 0 is 0, so 0 is equal to 0. That is a true statement, so that means that h has to be equal to 0.